Hello, I am Radhika Chanwadkar from MVP's KVT College of Engineering, Computer Department. I am going to present this video on different searching techniques used in data structures. The objective of this video is to make the students understand different searching techniques, to analyze the searching techniques based on the concept of time complexity, and to effectively use the searching techniques for solving real-world problems. So basically, what do you mean by searching? It is a technique of locating the position of the required element. Sorting is the process of arranging the data in the desired order. So after sorting, the required element can be easily located. So searching technique is even applied on the sorted list, but this is not mandatory. Searching can even be applied on non-sorted lists. The element to be searched in the list is called as the key element. There are some basic characteristics of the searching algorithm. These are: the searching algorithm should be efficient in time, it should involve less number of computations, and the space required for performing the search operation must be less. With these features, there are different searching techniques in existence, like the sequential search, which is also called as the linear search, sentinel search, binary search, Fibonacci search, and index sequential search. These are the various searching algorithms. We will be discussing some of these searching techniques in this video. Let's start with the sequential search or the linear search. Sequential search is a technique in which the given list of elements is searched from the beginning. The key element is compared with every element present in the list till the desired element is being found. If the match is found, then the searching process stops. Otherwise, the searching process continues till the end of the list. This is a simple method, but it requires a large number of comparisons. In the worst case, the entire list needs to be searched, and then we can conclude that the element we are searching is not present in the list. It does not require a sorted list. This technique can be applied on any kind of the list. So as we discussed, the worst case time requirement is the total number of elements present in the list. Hence, the time complexity of this algorithm is big O of n. Now let's have a look at the example of linear search. Suppose we have given a list of elements and that is stored in an array. Consider that the key element to be searched is 25. So it will be compared with all the elements starting from index 0. The search continues till the desired element or the key element is being found. It is observed that the key element is being present at index 7. So the comparison will be starting from index 0. It will be comparing all the numbers sequentially till it gets the desired element, that is 25. And when the 25 number is being found, the search stops. And it will be indicating that the search is successful. Now let's consider that the key element to be searched is 1. Starting from index 0, each number will be compared to search the number 1. But number 1 is not present in the entire list. So the comparison will continue till the entire length of the list, and finally we can conclude that the element is not present in the list. This is the worst case scenario in which all the elements present in the list will be compared. Let's have a look at the pseudocode for this linear search. It's a simple search algorithm which starts from index 0 up to the length of the list. It will be comparing each element with the key. If the element is being found, it will be returning successfully 1. If the element is not found, it is going to return a value 0. So that's the simple code of linear search. A slight modification in the linear search gives the sentinel search. Sentinel is a value which acts as a dummy data in the algorithm. It is used as the condition for termination. In sentinel search, the key element itself is appended at the end of the list. Hence, the search will never be an unsuccessful search. It will be always terminating successfully. Sentinel search requires that the array has some space to store the extra element, which is called as the sentinel element. This algorithm also does not require a sorted list. It can be applied on any kind of the list. And the time complexity of this sentinel search algorithm is big O of n. Okay, so sentinel search is the slight variation in linear search in which the sentinel value is being appended at the end of the list. Let's have a look at the example of sentinel search. A list of numbers is being maintained in the array, and consider the key element is 25. It is appended at the end of the list. So you observe that the element will be added to the end of the list. The search terminates when 25 is located at the last position. If it is the sentinel element, we can conclude that 25 is not present in the list. Similarly, consider a case in which 11 is being appended at the end of the list. Now the comparison starts from the first element, and whenever a match is being found, the search stops and it is being returned. Now the position is not the end of the list, so a number 11 is present in the list. We can conclude that it is present at index 2. So that is the sentinel search. The pseudocode for sentinel search is we are passing the array being stored, storing the elements, the key value and the total number of elements. The key is being appended at the end position of the array, and then starting from index 0 up to the key is being found, the search continues. If the key is being found at position I, which is the last position, then it returns I value, that is indicating the unsuccessful search. Whereas if the key value is not the last element, then it is the successful search. Else, if the key value is the last element, it is going to return the unsuccessful search. So that is sentinel search. Let's have a look at the next searching technique, that is the binary search. Binary search uses divide and conquer strategy to search a key in the sorted list of elements. List of n values sorted in ascending order are stored in array A. The key element to be searched in this list is using the binary search technique. In binary search, the first comparison is made with the middle element of the list. If the element is present at the mid position, or if the key is found at the mid position, then the search terminates. But if it is not present at the mid position, then it is compared the key to be searched, whether it is less than the element present at the mid position or whether it is greater than the element present at the mid position. If the key is less, then the left list preceding the mid will be searched. If the key is greater than the element at the mid position, then the search will be continued in the right list, which is following the mid position, to check for the search element. These steps are repeated till the key element is found or till the further division of the list is not possible. Ultimately, we can conclude that the key element is present, or if the division is not further possible and if key element is not found, we can conclude that the element is not present in the list. In each of these iterations, the list is divided into half. Hence, the time complexity of a binary search is big O of log n. Let's have a look at the example of binary search. Here we are having an array of elements which are being stored from index 0 to 8. You observe that binary search requires the elements to be in sorted order. So binary search can be applied only on sorted data. Let's take an example that we are searching for the key 25. The first step is the comparison is done with the element present at the mid position. So first the mid position is computed. The low end is having index 0, high end is having index 8. So the mid position is index 4. The element present at index 4 will be compared with the key element. That is 15 and 25 will be compared. Okay, there is no match, but 25 is greater than 15. So the search will be restricted now to the right list. Hence, the low will be modified to 5, high will remain 8, and the mid position will be computed as 6. The element will be compared, that is 23 is compared with 25, no match. So again the element is greater, so search in the right list. So again the low value will be modified to 7, high value will be remaining as it is 8, and now the mid position comes out to be 7. The element will be compared and you get a match, so the search terminates successfully. Now let's have an example for an unsuccessful search. Let's observe that we are searching for the element 5 in this sorted list of elements. The first comparison will be with the element at the middle position, that is 15. 15 will be compared with 5, but 5 is less than 15. So the left list will be searched. The right list will be discarded from the search. So as the left list will be searched, the high end will be modified. Low will remain 0 as it is and high will become mid minus 1, that is 3. So the mid position comes as 1. The element will be compared with the element at index 1. So 5 will be compared with 7. But 5 is less than 7. So the left list will be searched. Okay, now here the low value will be 0. High value will be 0 and the mid position also comes out to be 0. But the element is not found as a match. So we have to search as the element is greater. 5 is greater than 3, so we have to search in the right list. But there is no further right list possible because low is becoming 1 and high is 0. So as no division is possible, we can conclude that the element is not present in this list. The pseudocode for binary search is very simple. You are having the array, the key element to be searched, the low end and the high end being passed. Okay, the process continues if low is less than high. The mid value is being first found out or the mid position is being computed. The key element is being compared with the mid element. If it is a match, mid value is returned. If it is not a match, it is checked whether the key value is less than the element at the mid position. There is a recursive function called to binary search with the left list passed as its input parameter. Or if the key value is greater than the element at the mid position, then the right list will be passed with the modified lower end as mid plus 1 up to high. So that is the pseudocode for binary search. The references used to prepare this video is the book Fundamentals of Data Structures in C++ by Horowitz Sahni. Thank you for your patient listening.